So the first section of this module is really going to be based around functions of real variables and exploring how we can use those functions which give us representations of how variables interact with each other to build up our pictures of models of engineering systems. So to start with, we need to define a few concepts of what we mean by functions. You'll all have met the idea of functions many times already in your previous studies, but we just need to make sure that we're agreed on the notation that we're using so that we can then go on to study the behavior of functions. So this first video lecture will be based around what we mean by the definition of functions, and then a couple of concepts associated with that, the range and the domain of functions. So the idea of a function is really quite simple. We're focusing in this module initially on real functions, functions of real variables, and we can extend that later on, but for the moment, what we mean by a function is that if you're given a real number, then a function is an operation you can perform on that gives you a unique real number output. And so if we consider the input number to be x, we're going to represent it by x, and the output y, then what we mean by y being a function of x is that we would write that in the form y equals f of x, and what that means is that for any given number x, you can perform this operation f on that number, and it gives you a unique output y. And that's an important point for the definition of a function, is that for any given x, the output that you get y is unique. So there are certain operations that we're familiar with that we'll see later don't give a unique output, and so those aren't formally functions. So we'll see examples of that later on. So a little bit of notation that we use mathematically here. So f is our function in here. X is what we call the dependent variable, the independent variable. I apologize. Get that right. So the input to our function is what we call the independent variable. The output, which obviously depends on our value of x, we call variable. So those are our basic notions of the input and the output to a function. And as I say, those are the independent and dependent variables. Now, in many cases for a function like this, the possible values x that you can feed into your function that give a unique output y are restricted. You can't put in any possible number you like. So if we think of a very simple example of a function, if you say, I'm taking a taxi ride somewhere, then I want to know how much that's going to cost me. I want to know what the cost of the taxi ride is. And what that depends on is the distance you're going. And so in that case, the independent variable, the input, would be the distance that you're traveling, and the dependent variable, the output, would be the cost of your journey. And so that gives us a very simple example of a function where I can feed in a distance, and for any given distance, you'll get a definite cost. You won't get two or more different costs from the same taxi. And so this is an example of a function. But here we can see immediately that the distance I can feed in can only be non-negative, and in reality, it wouldn't be zero either because you're not doing a journey there. So the input can only be a positive number in that case. So it doesn't make sense to feed into this function a negative number, a negative distance. That wouldn't give you back a cost, because that doesn't really make any sense in this context. So in this case, we can see that there's actually a restriction on the sensible values of x that we can feed into this function. And in that case, it's just x is greater than 0. And what we call that set of numbers that are allowed inputs to our function is just the domain of our function. So the domain of our function is just the set of allowed x. And that's an important concept that we need to bear in mind for functions, because very often that won't be all numbers. It will be only a restricted set of numbers. And so, as I say, in this case, the domain of this function that gives us the cost of a taxi ride is just x greater than 0. So that's our restriction on the range in here, on the domain in here, sorry. The next concept that we need to worry about is that we don't have all possible numbers as outputs to our function. So again, in this case, in the case of the cost of a taxi journey, for example, then the possible outputs of the cost are actually positive numbers. And in fact, in the case of a taxi ride, if there's a minimum fare, then the output will actually only be greater than or equal to that minimum fare. It will be restricted. And that set of numbers that are the allowed or possible outputs of our function we call the range. So that's the range of our function, and that's the set of possible y values that we get out from applying our function. And in this case, as I say, for a taxi journey, we'd actually have a minimum cost that you always have. Which is some number that's a positive number that's our possible set of costs for our taxi journey. So this tells us that if we have this idea of an input x giving us a definite value y, then we very often have a restricted set of inputs for domain and a restricted set of outputs, the range, for our function. So those are important concepts associated with any particular function. So let's just see another example. So if I make some room, I'll just leave that example there for a moment. If we now think of a more mathematical example, so if I were to say, let's consider the function that's just given by squaring numbers. So if I say y is f of x is equal to x squared, then the domain in this case is all values of x. I can take any value of x from minus infinity to infinity, and I can square it and get a definite output. So the domain is just minus infinity to infinity in that way. And there's another way that we can write this in set notation that you might see, which is just saying that x is contained in the range minus infinity to infinity in there. But now what about the range? Well, if we square any number, we get a positive number, or 0 if x is 0. So the range is actually not all numbers, but it's x greater than 0 and less to infinity. It's only non-negative numbers. And again, we can write this as x is in the range 0 to infinity. There's a little notational detail here in that if the range is inclusive of the left-hand limit, or the right-hand limit for that matter, then we use a square bracket to indicate that. So that means x can go to 0 and include 0. Whereas when we have the round bracket notation, that means x can go up to that value but not include it. So that's just a kind of notational nicety, if you like, of our functions. So that's the idea of domain and range. And as I said at the start, you've encountered functions many times before. And functions that crop up again and again in maths and in applications are given special names, and they're called elementary functions. And so just to highlight some of those functions that you should be familiar with, and you probably know what their properties are, then some elementary functions are given by, so for example, y is x to the n, some power of x, and we just saw the example of x squared as an elementary function. Or you could have the trigonometric functions that we'll meet many times during this module in different contexts. And then some other examples of functions you will have met would be the exponential function and the logarithmic function. And then there are probably more that you can think of, that you've encountered before, that, again, we will be encountering time and time again during this module. So we need to get familiar, or remind ourselves at least, about the properties of these functions during the tutorials.